Hello, and welcome to CRPS Contender, my complex regional pain syndrome education channel. Today's video is Mutilated Movement Master, Brain Structures and Functions, Basal Ganglia. This video is part of my Mind as Matter mega series, so if you would like to watch these videos in order, here is the listicle for you. Let's hop right into the content. The basal ganglia, also known as the basal nuclei, has strong interconnections to the cortex, the limbic system, and the brainstem. If you look over to the right, the basal ganglia is this dark navy section, and you can see it wraps all the way around the limbic system, sitting between the limbic system and the cortex, and the limbic system and the brainstem. The basal ganglia has multiple individual structures that work independently of each other, but they also coordinate in a network. Basal ganglia contributions are complex and not completely understood, but they probably have multiple movement-related functions and are related to balance. Basal ganglia is linked to the initiation and execution of movements and facilitating desired movements and inhibiting unwanted or competing movements. It works on two major pathways, the direct and the indirect pathways. I am not going to get into either of those, but if you would like more information on that, I recommend checking out my nervous system playlist that I'm curating, where I have multiple different specialists and neuroscientists who, actually went to school for this, who will explain it there and probably do a much better job than me. So check that out if you would like more detailed information. Basal ganglia is split into two major sections, the structures that belong to the striatum and the structures that don't. First, I want to talk about the structures that belong to the striatum. First structure I want to discuss is the caudate, which just means tail. And this is responsible for voluntary skeletal movement, the planning of movement execution, learning, memory, reward, motivation, emotion, and romantic interaction. The putamen, which is there in the center, means the shell, or hard covering, and it is responsible for regulating motor planning, learning, execution of motor movement, motor preparation, specifying specific movement amplitude, movement sequencing, movement selection, and the automatic performance of learned movement. The nucleus accumbens, which is that red section down there at the bottom, means the reclining core, and it is responsible for reward, reinforcement, maternal behavior, aversion, and slow wave sleep. Now let's talk about the non-striatum structures. The globus pallidus, which just means the pale globe, means it's there right in the center, regulates subconscious motor actions and inhibitory actions to balance the excitatory actions of the cerebellum. The subthalamic nucleus, which you can't actually see on this particular graph that I've chosen, means under the chamber core, and it sits right beneath your thalamus, and it is likely involved in linking decisions that require high cognitive burdens to motor processes. And then the substantia nigra, which you also cannot see on this particular graph that I've chosen, means the black substance, and it is the major dopamine producer in the brain, and also it's responsible for eye movement, motor planning, reward seeking, learning, and addiction. If you are experiencing basal ganglia dysfunction, and in CRPS, this is one of the 5 major areas that are affected according to the 2018 dendritic cell hypothesis, what would you be expecting from that? Hypothalamic pituitary complex stimulation, which means your hormones are out of whack, a dopamine dysfunction, limbic system dysfunction, and sympathetic nervous system dysfunction. You can experience some hypokinetic orders similar to Parkinson's, or hyperkinetic disorders like Huntington's. This is where dystonia would fall, which is those uncontrollable muscle contractions. And then there is another subcategory of disorders that are not clearly hypo or hyperkinetic, like Tourette's or cerebral palsy or twitching eyelids, things like that. You will also likely expect personality changes, apathy, irritability, and depression. So this was a basic overview of basal ganglia structures, functions, and dysfunctions. Thank you for watching. As always, relevant sources are linked below, and I look forward to seeing you in the next video.